You ever have this happen? You click a link, and bam, the page is just there. It's instant. But then, the very next link you click, you're just staring at a white screen, waiting and waiting. So what is the secret? What's the difference between a site that flies and one that crawls?
Well, the answer is a really powerful and kind of invisible system called caching. Honestly, it's the unsung hero of the modern web. And today, we're going to pull back the curtain and see exactly how this whole thing works.
All right, so here's our game plan. We're going to follow the secret journey of a web request. First, we'll talk about why caching even matters. Then, our first stop is your own browser. After that, we'll hop over to the CDN, then go deep into the server itself, and finally, we'll get into some really cool modern tech called service workers.
So, at its heart, caching is a pretty simple idea. It's all about storing copies of files, images, code, that sort of thing, in a temporary spot that's really easy to get to. The whole point is to access them way faster the next time you need them. And the difference this makes is, well, it's huge. Think about it. Without caching, every single time you click something, your browser has to make this long-distance call all the way back to the main server to download everything from scratch. But with caching, the website's way smarter. It remembers what you've already seen and just grabs those files from a place that's much closer to home. So let's start at the closest possible spot, your very own web browser. The best way to think about this is like your own personal library. It keeps all your favorite books and resources right on your desk, so you don't have to run to the main library every single time. This is often called HTTP caching, and it's all controlled by these little instructions, or headers, that the web server sends along with the files. You can think of these headers like little sticky notes. When you visit a site, the server might attach a note to its logo that says, "Hey, you're going to need this again. Just hang on to it." And your browser does just that. It stores it right on your computer. The main instruction for this is a header called cache control. It can say things like max age, which tells your browser, hold on to this file for, say, 1 year and don't even bother asking me about it. Then there's no cache, which is a bit weird. It does let the browser store a copy, but it says, before you use this, just do a quick check-in with me first. And then you have immutable, which is the ultimate promise. This file right here, it will never ever change. Don't even think about asking. Just use the copy you have. So how does that quick check-in actually work without re-downloading the entire file? That's where something called an ETag comes in. It's basically a unique fingerprint for that specific version of the file. Your browser tells the server, hey, I've got a version of this file with a fingerprint XYZ. If the server looks and sees its version has the exact same fingerprint, it sends back a tiny, super fast response, 304 not modified. It's basically the server saying, yep, you're good, use what you've got. This saves a ton of data and time. Okay, but what if it's your very first time visiting a site? Your browser cache is totally empty. What then? Well, that's where the next layer of speed comes in, the CDN, or Content Delivery Network. If your browser cache is your personal bookshelf, then a CDN is like a global network of local library branches, scattered all over the world. So here's the deal. A CDN takes a website's static files, the images, the style sheets, the big video files, and it stores copies of them on servers all across the globe. So when you, sitting in London, ask for a file, you don't get it from a server in California. You get it from a server that might be just a few miles away. This massively cuts down on what we call latency, which is really just the physical travel time for that data. All right, so we've sped up the delivery, but what about the origin of it all? The main server has its own caching tricks up its sleeve. Let's go back to our library analogy. This is like the main library keeping a cart of its most requested books right by the front door, so they're ready to hand out in a second. There are a couple of key types here. First, there's database caching. This is where the server saves the results of really common and sometimes slow database lookups. So instead of asking the database for the list of top 10 articles every single time someone loads the homepage, it just keeps that list handy. Then you have object caching, which stores more complex, pre-built chunks of data, like a complete API response that it knows it's going to have to generate over and over again. Now, up to this point, pretty much everything we've talked about is based on rules set by the server. But what if developers want to get their hands dirty and have total, fine-grained control over how caching works? Well, that brings us to our final and honestly most powerful layer, service workers. Service workers are really fascinating. It's a bit of JavaScript code that your browser runs in the background totally separate from the actual web page you're looking at. It basically installs itself between your web page and the network, and it acts like a super smart, fully programmable traffic cop, inspecting and handling every single request that goes out.
This programmability allows for some really clever strategies. Take a cache-first strategy, for example. When your page requests a file, the service worker jumps in and intercepts it. First, it checks its own special cache. If the file's in there, boom, a cache hit. It serves it back instantly. No network required. Ultra fast. If and only if the file isn't there, then it goes out to the network to get it. And here's the clever part. It then stores that new file in its cache for the next time around.
So what's the ultimate payoff for all this control? This quote really says it all. Because a service worker can grab files directly from its cache, it can make a website work even when you have zero internet connection. This is the magic that transforms a normal website into what we call a progressive web app, or PWA.
So let's just put this all together on a kind of speed ladder. At the bottom, the slowest option is a request that has to travel all the way to the origin server. A step up from that, much faster, is getting a file from a nearby CDN cache. But right at the top, the absolute fastest experience you can get is when the file is served from a cache that's already on your device, either from the browser's regular cache or from a clever service worker.
The big takeaway here is that caching isn't just one single thing. It's this whole stack of different layers, all working together to make your web experience feel instant. So now you know the secrets. The next time a page loads in the blink of an eye, you can try and guess. Was that my browser cache? Was it a CDN? Or maybe was that the magic of a service worker making it happen? You now have the map to that invisible journey.